Welcome to The Long Game, a podcast by Macau Group where we sit down and have raw conversations with talented specialists and people who are passionate about what they do in the built environment. My name is Kelvin and I lead the team here at Macau. You can check us out at macau.com.au to learn more. That's MAAO.com.au. This is Volume 1 where we explore the ins and outs of energy efficiency in buildings. Today's episode features Ash Mogensen, one of the founders at 3Arc. 3Arc provides airtightness, building performance assessment, and thermography services across Victoria. Leave the door to your mind open and enjoy the conversation. Thank you for making time today, Ash. To kick off the conversation, I think it would be best for Ash to maybe just introduce yourself and Arc, just in terms of what you do and some overview.
Sure, thanks for having me here today. Ash Mogensen from 3Arc, and our company provides airtightness advisory and testing services. We also do thermography or infrared imaging, and we also do home energy assessments using the Vic government scorecard tool. We started in the airtightness arena around about early 2015, and with the expectation that we'd see some changes in our industry with the 2016 NCC code regarding airtightness. But that didn't occur, and it wasn't until about 2019 we finally saw airtightness appear in the code as an option for determining how well sealed the building is.
Yeah, there's some items you mentioned there that I'd be keen to expound on. But before we get onto that, I'd be keen to hear more about your personal, your journey in terms of how you got into the space. Is it something that you've always been doing as part of your career, or is it an opportunity you saw at some point and decided to pursue it?
Yes, it was the latter. I had an industry in the telco space for 20 odd years and finished in that area around 2010. I had some sabbatical time. And with some friends was looking at business opportunities.
Mm-hmm.
And one of the friends talked about building airtightness. So we had a look into that and we thought, well, that's a really great area to be in because we saw our country relative to, say, countries like the UK and some parts of Northern America where airtightness had been in use for quite some time.
Mm.
And also had some experience with some expat friends who came to Australia, and those who lived in Melbourne. For example, one guy came from Sweden,
mm-hmm.
and he said he's lived in different places around the globe, but he was the coldest in Melbourne.
Oh, wow.
And he said, I think your housing is, he said, I'll be nice, I'll call it a glorified tent. So that always stuck with me. And when I visited his place when he went back to Sweden some years later, I was there in the late 90s. And the home was airtight. It had ventilation, double glazed windows, and it was just a comfortable space to be in. So that was some of the sort of early experience of what better housing could be like.
So you got to see it firsthand and experience it firsthand as well.
In terms of building airtightness, we thought for the country and for people in their homes, that's a low-hanging fruit in terms of the cost to get better airtightness. It's not huge.
Mm-hmm.
There's a lot of DIY stuff on the web that can show you how to seal, for example, your external doors better and so forth.
Mm-hmm.
We just thought that was an industry that would grow and we could grow with that.
Over time.
And, it's something very passionate about. And we do some things like we work with the Renew organisation and we give up some time there to do a speed date. They arrange those in council areas where you can talk to an expert, for example. We find that when we're talking about where the industry's at, we do spend a bit of time making people aware of what airtightness is.
Yeah.
For quite a lot of industry participants,
I
may have heard of it, but not many have built buildings with airtightness in mind in terms of a design and a construction method to achieve better sealing as you go through the layers.
Yeah, gotcha. One of the other things I do find fascinating is usually the naming or the names behind different organizations and institutions. And I see yours is 3Arc. Is there a story behind the name?
Yeah, in terms of the name, coming up with a business name, the ARK represents the initials of the directors, the three directors. So it's me, Ash, Ratko, and Costa.
Nice.
And being three of us, 3Arc, we liked the name of it. We thought Arc was a robust, strong sort of name. Unfortunately, we had the benefit at the time didn't realise, but it's helpful in the listings in the digital world because the tree tends to sit on top of the listings. And funnily, for an organisation we met on along our travels called ARC Resources, they provide conceptual services and ESD type services. So it was, funny, we ended up working with them on some projects, but people think, oh, is that a subsidiary?
It's very fascinating. And to zoom out a little bit, it's more of a reflective question. So you've been in this space since 2015. How's the industry changed from your perspective from 2015 to now 2021? Are there some changes? Are there some trends that you've observed so far?
Yeah, for sure. In any country, it does need the equivalent of the National Construction Code to set the agenda for any sort of changes. There are some participants who will explore themes that look beneficial when looking at what countries do overseas in similar climates. For example, Melbourne being a cooler climate. What we've seen is, I guess, there's some pioneers in this space. In terms of commercial, Green Star's been good in terms of introducing air tightness. Just do a test to get an innovation point, to now requiring from the construction aspect of Green Star, you need to do a test, no longer as an option. And initially they had targets that were very easy to achieve, like a permeability of 20. That's as in metre cube per hour per square metre of surface area of the building. Whereas the NCC code that came in 2019 with air tightness testing as an option, for commercial that is 5, and for residential it's 10. As in to get less than or equal to those numbers.
Moving towards the definition side of things, how would you define airtightness?
Probably the best way to describe it for any type of building, what airtightness is about is you controlling what air leakage you have. So what it's about is eliminating unwanted air infiltration. And the reason for that is that if you've got a building and leaks coming from anywhere, you don't know where they're coming from. So some source could be contaminated air, like if you're on a busy road and that's where a lot of air's coming in through the front door, you're getting a lot of vehicle emissions, for example. So it's a verification test. And there are those sorts of tests when a house is built. For example, the plumbers have to do a pressure test of the pipe system so that achieves the pressure, there's no leaks in the pipes. The electrician has to do a resistance test of the cabling. So there are some of these specific tests done, and air tightness is just another one from how well it's been constructed. So the way that it's measured, we have an adjustable door frame that goes in an external door of the home, could be the front door or the back door. And then inside of that we have a cloth insert, and then that goes a fan. There's different terminology. Some people call it a blower door. It's actually a fan rather than a blower. And that fan, you can create either negative pressure or positive pressure in the building. Ideally, it's negative because when you do the test, you can, when the building's under depressurisation, it will magnify the air leakage issues in the home. So we test typically from about 20 pascals to 60 pascals. And then the result is expressed at 50 pascals. And having a number, that then allows you to compare different types of buildings. So air permeability is about the flow, which the fan measures, divided by the surface area, square metres. So if you've got a building, 4 walls, a roof and a floor, total up those areas and divide that into the flow that's measured for the leakage, and that gives you the air permeability. Then there's another way to express it based on the volume of the building. So passive house has been around since the 80s, and they decided on volume. So that's expressed, instead of dividing it by the area, it's by the internal volume of the building. And passive house has got one of the most stringent air tightness standards. It's down at 0.6 air changes per hour, 50 pascals, and it's approximately equivalent to 1 air permeability or 1 metre cube per hour. It's an approximation because different shapes, for example, a cube is more efficient from a volume point of view for the surface area compared to a rectangle. So we like air permeability because it allows you to better compare different shapes, building shapes, whereas the closer you are to a cube or a sphere, your air leakage is going to be better because you've got more volume for the surface area.
Gotcha.
So that's the different sort of things that are out there. But you can represent the result in both ways because you're measuring the flow and you can calculate either the area and or the volume.
Yeah.
And then if you don't meet target, we then investigate for those leaks. So we have different techniques to find the leaks. They can be simply the back of your hand, a typical leakage areas, which can trace of smoke. So for those who've been to the disco with the smoke, we have portable ones and we have a large one that create a lot of smoke in the area. And we also have infrared imaging, which can give you a picture of what air leakage looks like, because it's not something you can image otherwise. You can sense it, but to be able to show a customer, well, what does it look like? That's what the infrared can help if you've got a temperature difference on the day. Yeah.
Nice. So with the air tightness testing, there are things that it has benefits and there are certain consequences that might arise when you don't do it. Maybe starting with what would be some of the benefits of undertaking that test that you just mentioned?
Yeah, well, the benefits of having a good air tightness mean that when you're either heating or cooling your building, depending on the season, you're going to lose less of that conditioned air. For example, CSIRO did a study around Australia around 2015, a mix of houses, new homes and existing homes. And the averages for those were somewhere in the teens in terms of air tightness. And their estimate at that time was that the homes that they tested were leaking about 30 to 40% of that conditioned air.
Oh, wow.
So you can imagine if you halve it or even reduce it by 75%, what a big difference it makes. One of my business partners, Ratco, his home was somewhere up around 19 air permeability. And when we got the fans, we tested our homes, and over time, he's reduced that down to about 4.5.
Oh, wow.
And then some of the differences that he notices are that he's no longer really aware of how windy it is outside because of the noise reduction of air leakage. There's less room for noise to travel. And what he's found too is that he's got a home with single glazing windows, but good curtains. And in winter time, since improving his air tightness, he's found that instead of the temperature dropping down to within a few degrees of outdoor temperature, it drops down to maybe 13 or 14, which is a lot better than down at 5, which means when you get up in the morning, you've got less of a temperature to get to, say, 19 or 20 degrees. And it also means that your heater runs less because it runs and then thermostat says I've achieved temperature and it just holds on to that
temperature
longer because you've got less air leakage. The other thing it does is, things like pollution or odours and even things like pests in terms of insects and rodents and things like that.
Yeah.
In some homes we've seen, especially under sinks with plumbing penetration, mice can get through those gaps. Yeah, you get that sort of benefit as well. And in terms of the occupant, what it means is not having drafts means it feels more comfortable. So one of the things we talk about is it's about comfort for people and efficiency for your building. And then you enjoy being inside and you're going to have less energy costs and therefore less demand on the grid and generate less CO2 emissions for whatever you choose to do in your home. So that's the air tightness. And the other side of the coin is ventilation. So what we talk about from an air tightness perspective is to build airtight and ventilate right.
Build airtight and ventilate right.
Unfortunately, with build airtight, you can't just say, I want to achieve a permeability of 8 or I want to achieve a permeability of 2. All you can do for your given design is build that as airtight as you can. And to give you an idea, if you go down to passive house construction, typically here they'll use an internal membrane, and that's the air barrier, so that when the house frame goes up, they then put the insulation in, and then they put this internal air membrane on. That's all taped up, and we come in and test at that point. And the idea is that if you pass at that point, then when you complete your construction, you should be confident you're going to meet the 0.6 air changes per hour target. Because that's very airtight, that means that 0.6 air changes out, that's at 50 pascals, and what that means at normal pressure, to convert from a 50 Pascal air tightness result to normal pressure, is the rule of thumb is you divide by 20. If you look at the passive house situation, you're down at 0.003 air changes per hour at normal pressure. So that'd be a very stuffy building. So the idea is by ventilating right, the passive houses will use Melbourne anyway, a heat recovery ventilation system. So that brings in fresh air and extracts the area typically from your wet areas, so your bathrooms, your kitchen, and delivers fresh air. And as it's exchanging that air, it takes the energy of the outgoing air and uses that to preheat if it's winter time, the incoming air. And they can range in efficiencies in the sort of 90s, low 90s to high 90s. Again, that just means that from an energy perspective, instead of having a heat air that could be in Melbourne in a really cold morning, 0 degrees, and get it to 20, have to put all this heat into that air. If you exchange the air going out at maybe 19 degrees and only losing, say, 10% of that, you've only got to add 2 degrees to that incoming air, which is a lot less energy than air coming in at 0. So there's those sorts of systems you can do. And what we see with calls, for example, people have come in and bought a new apartment and they're telling me they've got these condensation and mould issues occurring. So we've just compiled a document to assist people that we send to them. No charge if anyone wants to find out about that. And that just takes them through, well, how does condensation occur and what can I do? So if you've eliminated the sources of moisture and you're still getting a problem, then what that's saying to you is that it's quite airtight, but there's no ventilation coming through. So you can get these, instead of a whole house HRV system, you can buy these, they come in pairs, they're called decentralised HRV. So they're ideal for smaller things like apartments. And they just go in the external walls and they cycle roughly about a minute to 90 seconds. One drags air out and the other one brings it in and then it reverses. And they can be quite a good solution because they're about retail for the units, they're about $1,200 to $1,400 a pair.
Okay. And these are retrofits.
Yeah. So you've got to basically draw a core through whatever your external wall is and work out where you want to put those, but that's something that can be done. So, yeah, that's the two sides of the coin. At the moment, the ventilation side of things is taken care of because the homes can be quite leaky. A
lot of outside air coming into your internal space.
And I grew up in a home where we had wall vents back in the days, and where they actually connect to the internal wall, the air's not great there. So it's not a good place for it to be coming in anyway, but it's generally put in place for when we had the solid fuel burning, briquettes or wood and so forth, but disappeared from our code somewhere around the late 70s or early 80s. So one of the things we look at when we go into homes is people just accept that they're there, not really sure why they're there, but they're like little chimneys in your house. The hot air rises and is drawn out through the lower points in your home. So this is where you can have homes quite drafty. And for people who have a gas space heater or wood heater in a room, then they've got to have a fresh air supply of some sort. So if you have vents in those rooms, you're probably going to leave those. But funnily enough, there are solutions in this age we live in. Some people ring up about building a passive house and say, I want to have a wood burning fire place because I'm in the country and I like that look and the ambience and all that. What can we do? So I did some research and I found, for example, a product that's got a dual flue on it, a smart flue. So the incoming air is in one of the flues and the exhaust is in the inner one. So you don't need a make-up air opening in your home because it's all in the fireplace system. So when you do an air leakage test, that's not going to leak because it's a closed system. So there are things like that, products like that that are out there. Yeah, that's what we do. And countries or buildings vary. If we talk residential, around the globe, I think Germany's got the lowest air tightness result before they require continuous mechanical ventilation. And it's about 3.2 permeability. The UK tend to talk about it once you get into the low fours. But we've also seen some buildings where we've tested a conventional plaster build. It had air leakage test resulted 2. And we asked the occupants, does it get very stuffy in here? And they said, oh, it's kind of. And we said, you've got a great air tightness, but you really need to look at ventilation system because it's counterproductive open the window in wintertime when you're heating your home.
Yeah.
From that particular case, I lent the person my air quality detection system, and they just tried out a bedroom with the CO2 detection and closed the door. They were using the bedroom as a home office during the working from home COVID sort of period in Melbourne, shut down. And they said they were amazed once they shut the door, the CO2 levels just went off the chart. He said to me that you're going to be looking at one of these retrofit systems you can get, a HRV. Yeah. So they have these ones where you can put them in a home, where the system goes in the ceiling and you put your ducts to the room, providing you've got a roof cavity. And those systems retail for about $2,500 plus the ancillary ducts and so forth, which might be maybe another $300 or $400. And yeah, those can be a good solution for people who have improved their air tightness. And now I was just wondering about the air quality.
Air quality. So it sounds like once you tick the air tightness box, then you also need to consider the ventilation of how you're going to ventilate the internal spaces as well.
That's right. Yeah.
Otherwise, you have all these other things that may come up, whether it's the stuff in there, CO2 concentration increasing over time, et cetera, et cetera. Is that right?
Yeah, that's right. So with the CO2, it's not the situation where you're going to pass out in the house, but it does affect your mental abilities. You know, what they talk about, different levels. You could look up a chart and say, at this level, you can become
sleepy.
Yeah, sleepy, drowsy, or your cognitive power decreases and those sorts of things. Yeah.
Especially in wintertime when we rarely open our windows because of the cold air outside.
Yes.
Yeah.
Yeah, unless you're hardy and you're used to really cold temperatures. Some people just have their windows open all year out. They come from a different era where, I like the fresh air. Yeah. And you go, it's pretty nippy in here. But there are some who do that.
Yeah.
But, yeah. And I guess with regard to that, you can see why the NCC started off with the 10 for residential, because they typically don't have a ventilation system other than exhaust fans in the wet areas. Whereas commercial are always generally going to have some mechanical ventilation system. So once you have a mechanical ventilation system, super air tightness is what you want, because then you're reducing the level that it exits the building.
Yeah, as much as possible. We've touched on a few things that I wanted to cover later on, but we might get back into them. Maybe on the flip side would be what happens whenever we don't do the air tightness testing. What happens when we don't pay attention to that, either at the design or construct phase?
Well, if you don't pay attention, basically you don't know how airtight your home is going to be. And sometimes the only way people find out is bill shock. They get through the first winter because they're heating the house every day. Because in summer, we're not necessarily cooling our house every day.
Yeah.
Use it a lot less number of days you need to turn your aircon.
Yeah, it'll be those 10 or so days that you have 30 plus. Yeah.
Yeah, but in winter time, once we get into the May period through to late September and even recent years, so I know one of my friends in the country has been turning their wood fireplace on in November as the temperatures dropped and it's been quite cold. We certainly spend a lot of dollars on heat. So with the bill shock, I mean, if I've purchased a six home, then what that means is that it's going to require a certain amount of energy in the form of heating to live comfortably through the year. So you can look up what energy requirement a 6-star house requires to heat. And as you keep going up in stars, you reduce the amount of energy that's needed to hold onto that temperature. So your passive house, you're going to be using very little. Some people don't even have a heater. They start off just assuming the people in the house and appliances is going to be sufficient heat for them. And you can look up some videos on YouTube where people in a passive house come home after a holiday and turn on their hairdryer to provide some heat. Yeah, just to illustrate how efficient it is, how it can quickly achieve a temperature. But yeah, that's what you tend to find out. You might have drafts and you might find, for example, why is this part of the home really cold? I can never get temperature right here. It's comfortable in this part of the home, but another family member saying it's cold down here, turn the heater up. So you get these imbalances that can occur. And a similar thing in a commercial building with the hot air rising, that's multi-levels. Depending on how connected different levels are in buildings, you can find that people on the higher floors in wintertime are feeling really hot, and those on the lower ones are feeling cooler and wanting to change the thermostat. So you can have this fighting requirement sometimes in the building. Yeah, with the air tightness, in terms of not having it, you're going to see it in your bills and also in your comfort.
In your comfort as well.
Yeah, that's where I notice it. So it's a bit like if I go out in wintertime and it's cold and I put on my coat, if I don't zip up the coat, yeah, my back might be a bit warm, but I'm going to be still losing heat through the front of my body where my organs are too. So it's not until I zip that up that becomes well sealed, because it's only at my neck and where my hands come out, and usually they've got a bit of elastic around the waist area to hug it to your body. So that's what it's like in your house. When it's well sealed, it's like you've got that snug jacket on, and despite the wind, you still feel comfortable. But yeah, unzip your jacket, and then you've got that not quite right. Part of my body's warm, but this other part's not.
Yeah, because you have all these points where outside air can get into your body. From your experience, what do you find to be points of weakness in terms of facilitating air leakage into a building or into a home?
In terms of where a lot of the leakage occurs, if we look at the shell of the building, for example, if someone puts in a chimney and they don't put a damper in, then that's a massive air leakage issue. And the chimney draws, so it means when you are heating it, the hot air's rising. So we do see some people with that as a feature. They may not be using it, but if you haven't got a damper, you've introduced this hole into the house.
How does the damper work in terms of mitigating some of that heat loss or air loss?
So the idea with the damper is that it'll be on the top of the chimney, and it's like a flap. So you have a chain that comes down the chimney and sits on the hook in the fireplace. And when you want to use the fireplace, you open the damper, and when not, you have it closed. Another area can be exhaust fans. It's only recent times that having to put in an integrated damper fan system has made it into the code. So a lot of people live in homes where there's a fan in their bathroom, could be laundry too. It's there with a cover on it, but if it doesn't have a damper on it, it's another hole in your home. The worst case is if you've got a whole home heating system, you're pumping heat into these areas, and it's just leaving through any sort of areas or openings that are up high because the hot air is rising. That's where you're going to lose a lot. So wall vents for older homes. And then, of course, we've got doors, outdoors, so it can be doors to the backyard and front yard, or even the door to your garage for those who have an access through the garage door. If you don't have sealing around those systems, that's where you can get a lot of air leakage because you've got the lineal meters of that door frame. So that's another area. We also see the architrave, because the way the house is constructed, the architrave covers the gap between, say, your door or your window frame and the wall of your building. So when the architrave goes on, that's got to be well corked so that there's not an air leakage into the home. And a weak point we can see is the top architrave, because it's out of view for most of us, unless we're basketballers. That's not corked because no one's looking at it, and you can get air leakage, occurring there. So there's a range of different things. I've mentioned earlier things like undersink penetrations of your plumbing can occur there. And then, of course, skirting boards. If you've got, say, wood flooring, there's a gap between the wood floor and the wall. And then your skirting board goes on to cover that transition, if you like, between the wall and the floor. And takes out that gap. But if you don't cork the skirting board, again, you've got another sort of leakage source with regard to that. Some of the other ones
that are a little bit more obscure.
That's coming into that can be things like the range hood in the kitchen. When that's constructed with the flue that goes through the ceiling, if there's a gap that's not corked or sealed around that area, when the cabinetry goes on, that can then mask that, and you can have an air leakage there that can manifest, especially if you've got like a wall oven. You can feel it around the ventilation of that. And probably one that can be quite large is the cavity sliding doors, so the cavity pockets.
Yeah.
And we've seen on a new home a couple of years back now where a customer just wanted to find air leakage sources and have us look at insulation with our thermal camera. We turned on our fan system and we heard a thunk and thought, gee, this is an unoccupied house. What could that be? So we ended up investigating. We found the ensuite door was a cavity slider door, and it was closing under just 30 pascals of pressure. Had that much air leakage coming through the cavity.
Yeah.
And because that's out of sight, it's only an area that perhaps on a windy day you might be aware of. But yeah, getting that constructed right so that there's no air leakage is a good one. Because I've sometimes seen a home, say, 9 of these doors in the home, because it can be quite an efficient space saver for how a home is constructed. And yeah, so when you add all that up, there can be quite a lot of air leakage. Another one can be for people with ducted systems, for the heating and cooling. That's probably the only one visually I can't tell you whether there's air leakage when I walk into a home.
By just looking at it.
Yeah. We can only see that when we turn the fan on. And if we feel draft from the return air, we know there's an open system because it should be a closed system. So one of the weak points there can be, especially in 2-story homes, if the return air, I'm talking about systems where they're in the level 1, the heater, for example, in the level 1 roof space, because it's on the slab. So the return air is down the bottom on the ground level, and they construct the shaft that's behind the cover to that. And if they haven't sealed that shaft, or it's not a ducted system, then the way it's constructed, you've got all these air leaks on this wooden shaft. So that means you've got an open system, which means when the return air is going back to the unit, it's also taking the cold air that's within the building, if it's wintertime, and introducing cold air into the system. Again, not what you want.
Yeah.
And other cases we've seen, sometimes it's just a duct has blown off an installation, or it hasn't been a good installation. The shape of the duct versus where it's going, connecting a flange to different shapes, and not a good job has been done. Maybe they ran out of the normal part and got what was left, and unless it's inspected or tested. And again, those things show up where people go, why is my heater always on? And that can be an example. If you are in a home, if your heater's always on, that could be the issue. You've got an open or a hole in your duct system somewhere. So it just means it can't hold temperature because it's always introducing cold air.
At some point, yeah.
That's a good one is thermostats on walls. Sometimes large penetrations are made. The thermostat goes on to cover that hole. And there's an air leakage point there. That's the worst type of air leakage, because if cold air is coming into your thermostat sensor, you're not really getting the true temperature of the house. It keeps saying it's cold. It wants to keep heating. Because the sensors could be, if it's a windy day and pulling air through there, then that can exacerbate things.
It's just misreading it.
And another one there will be reverse cycle systems, the service penetrations. Because the head unit goes on, you don't know how big the hole is where the penetrations are being made. So again, we can see that when the fan is running, and we've got some thermal images of that just showing the feathering effect of what air leakage looks like around the surrounding plaster. So that can be another area where you get those
potentially leakages.
Probably the other one, the main type one, is where you get different surfaces in the building. So if I've got a brick feature wall, for example, that meets a plaster wall on both sides, if I haven't caulked along the mortar courses and the bricks themselves, because the bricks are not where the plaster meets the brick, it's not a join. To our eye, it might look tight, but there's actually gaps because the surface of the brick varies, and the plaster will seep out in places, introducing gaps, and then of course the mortar courses. So testing the home like that for the first time, we actually see dust dragged in along the mortar courses of that. So that can be quite a large air leakage if you've got large wall and lots of these gaps. Another one can be with the ceiling, when you're putting timber boards in the ceiling. Again, where that meets the plaster wall surface, you've got a material that doesn't connect, because normally plaster where it meets plaster is then finished. It's corked, or it might have cornice on it as well, but it's an airtight barrier. But when you've got these different types of materials, yes, you can put a bit of quad over that, but the quad's not airtight itself. It'll reduce those, but the best thing is to seal it and then put your quad on, for example. And how you do that is, if it's something visible like the brick wall, you want to use a cork that goes on wide and clears, translucent, so it's to the eye, it is acceptable. Yeah, that's a sort of typical, a lot of the typical things that we see.
So the most obvious ones are the ones around the building envelope. Once you start moving to the internal spaces, it's a little bit more difficult to see with the naked eye, and you probably need to undertake the tests before you identify.
Around those sort of ducted type systems, or things that are covered, got a panel covering, and you don't know what that's like behind it. And just the humble GPO, we get a draft out of that when we test a home, conventional plaster lining sort of home. So it just shows you that, and we don't know where it comes from, but it manifests at that point. And that can be one of the issues with the air leakage, is that once the thing is built, you can't get to the source of it. One of the things we suggest to people, if you're really fanatical about air leakage, you can just get the child-proof GPO for those that are not in use, and just put the covers on there at that point, little plastic insert, and then you've cut off some air leakage from those.
Gotcha. Because I'm presuming some percentage of the work that you work on, they're already established houses or existing houses. What are some of the potential solutions that you recommend or provide to, say, a client?
For the existing homes, we get inquiries from people wanting to do an air tightness test, and we'll always say, look, we can do that, but what is it that you're wanting to achieve? Because to do an air tightness test, we also have to calculate that volume or the surface area of it, generally from plans, but there's some extra cost involved in doing that. And sometimes people just want to identify where the air leakage is. So that's a lower rate than doing the test and then looking for air leakage, for example. So it just depends. But there are, in terms of where typical air leaks occur, there are some good websites. You can look up, like Your Home, the government website. You can look up air leakage on that, and that has a picture of a home showing where the typical air leakage
points are.
We do get some customers, they want a baseline where they are at the moment, because they want to quantify what's the improvement that I get. We did a country town home built in the 80s, and it was quite leaky. I think up near 20 permeability. So they knew where some of the air leakage was, wanted to find out where was the house sitting, so they can, for themselves, demonstrate, okay, I want to get a test done. This is my baseline. I'm starting at 20. Identify where all the leakage points are. There were some that I could visually see, and then there were some other ones that we found for them. An unusual one can be your internal closets, where the roof of the closet makes the wall. It's out of sight. But in this home, you could feel drafts coming out of the closet, and filling up the closet between the roof of the closet and the wall, we could feel a gap. The finger went through. There was a gap between how it was finished. And we're talking, again, lineal metres, and it was present in just about all the closets that had been built. So it was an unexpected type air leakage. So their plans are to do the air leakage, remediate that themselves, and then look at doing a retest in the future. And what we said to people, we've worked with building a new home. You can do it as you go through the layers. So we provide a service where we can look at a design of a home and then look for these air leakage issues and provide what's the mitigation for that. How do I make it airtight? We can do it at that stage, but we often get called where the build's underway. We say, a good time to come out and talk to your builders when the foundation's done and the frame is done. We come out and talk to them about airtight or air leakage issues and how to build them better. It's not a lot of cost, it's just the attention to detail side of things. And a typical one we'll say is, for example, the bottom plate of the building is to cork between that and if it's on a slab, for example, because that then takes out what can be quite a lot of linear metres. You've got a wooden frame sitting on an uneven concrete surface.
Yeah.
Not at the visual level, it looks all right, but because wood on the concrete, you get all these holes in between that joints. So corking inside of that takes that one out right away. So that's good. And that's just an example. We also look at the insulation. There's some insulation weak points in how we construct our buildings. So we talk about those. One of the simple one of those is for the listeners is that having a hold point before your wall plaster goes on. Someone inspects that the wall insulation is in properly all the way around. There's no gaps. We can come around afterwards with an infrared image and saying, oh, that section of the wall's missing insulation. It's very costly to fix. You've got to break open the plaster, put it in, reseal and paint and have the impact of having this done in your home. Yeah, just a simple thing like that can improve it. It's really about this awareness because we do what we know, and it's not until someone says, hey, have you ever thought about this? And then you have a discussion and then you can demonstrate why it leaks and they go, oh, okay, well that makes sense, we can do that. And that's, it's not extra cost because it's that attention to the detail. So, for example, that corking around the external frame at the base to the slab, I asked one of the builders working, he said, it was about $150 extra.
Not much at
so
all.
if you think about it, you're spending in Melbourne, the average is a lot of suburbs now in that 1 million plus category. Whether you're spending on a house and land package, $500,000 up, whatever, but $150 is not a lot of money.
It's true.
To do those. So just getting those things done during the build. And then, we come and do the verification test. So providing the builder's taken on board the item we call out, then, we don't expect to see leakage at cavity doors and these typical areas that they occur. And sometimes we say to people too, we consider provisioning services for a ventilation system because some people just say, I want to do an air tightness test and I'm happy to accept the code recommendation of less than 10. But some others say, I want to get it as airtight as I can, but without the expense of putting in an air membrane. And from our experience, we've seen it as low as permeability too, but you do need the ventilation system there. So you can plan for that if you're in a smaller type thing like an apartment. You can work out where you put these decentralised piers and cable the power for them so that when you get in and do the air tightness test and say, well, I really need that, you can then fit those easily. You've made provision for them.
For the ventilation, And maybe just moving a little bit away from that, what are some of the changes you've seen in the NCC 2019, and are there some changes that you're anticipating in the one that affects the residential space, the NCC 2022?
Back when we started doing air tightness, the NCC was on an annual cycle, so 2015, but in the 2016 it went to a 3-year, so it meant now we've got a 3-year wait to do things. And looking at overseas experience, what they've done in terms of air tightness, there's been some talk about it. It starts off, for example, as an option. That gives time for the industry to understand it. Also build up the ability to test. And we've seen some changes in the testing industry where we've partnered up. We've got an Air Infiltration and Ventilation Association of Australia. But the president there had some talks with ATMA from the UK, which is a testing organisation, air tightness testing, about them helping us set up a testing industry here. So that means having people who are accredited, having practices, and also helping with communication of what air tightness is about and so forth. So they went on their journey where it started out. And to give you an idea, the UK had a target of 10. It came into effect. I think they had a 2-year warning of it, saying, right, 2 years' time, this is going to be it for the new builds. And that target, 10 years plus on, is still 10 today. The builders typically achieving the 5s, low fires because they looked at their techniques and saying, oh, okay, we can't dial up an air tightness, so let's address the air leakage issues and just make that standard practice. So anyone being trained in the industry, once Airtight was introduced, that's all they know. They don't know how it used to be done because this is now the practice. So they've got better buildings as a result and, achieving better than 10. So with our code in 2019, it was introduced under JV4 in terms of air sealing of a building. And it had a target there for those who chose that option of up to 10 air permeability for residential and up to 5 for commercial buildings. So that's been helpful because when I get some customers who ask about air tightness, I can say, you can talk to your builder and say, I want to have that option specified in my contract, JV4, and the target's less than 10, and we can help you out with how to achieve better airtight. That's been a good thing. Our next update for 22, instead of May, I was reading it's going to be September because of the COVID impact on the industry. And I haven't seen the proposal around the air tightness and condensation, but I did see that's going to be open for comment from about the 19th of July.
July 2029, yeah.
So I'll be looking to do that. And what's good about it is when they do that feedback, basically the update comes out a year before it comes into force, so people know this is coming. We tend to get that year notice with our code here. And sometimes too, like we had with the COVID, in terms of enforcement of that, a little bit more grace was gets allowed around those things in terms of the transition. I'm expecting to see Australia go down the same route of where it become a mandatory requirement because it means so much in terms of the energy use and also the comfort for the people in the buildings. So knowing what it is, that yes, I've met my target, I can say that's good. And I would say over time, because you can't dial it up, the builders will look at the practices and no doubt will end up being similar to the overseas experience, actually achieving better than that. And then, of course, people can specify different targets. What we say to people is that if you want to achieve less than 10, you need a considered approach. If you want to achieve less than 5 air permeability, it's a committed approach. And if you want to get down to those passive house type levels or 1 or better, it's a fanatical approach in terms of air tightness. So that means that your design features, one of those inputs is it's got to be an airtight
building.
The materials and how it's put together and the architectural features has got to be, if I want that certain look, it's not going to be expensive air tightness. So those things get factored in. What we can't do a lot about is that we see some buildings have an air tightness target in commercial space and then they put in a roller door. See that in like stadiums where they need a large door to get access to equipment. But that's going to have a big impact because it's very hard to make a roller door airtight if you've got multiples of them as well. But I guess what we've seen is this transition of actually having it in code as an option, and also the work Green Star's done of introducing it early on in the piece as a thing to do to get a bonus point. And now it's required if you are seeking Green Star as built, you've got to do an air tightness test. But what we've seen, at least in the commercial space, more buildings specifying that when we look for tenders have air tightness. And we're seeing more hands raised when we go out on our commercial projects. We have a methodology to help them achieve the end goal. And part of that is a kick-off meeting with their trade leads for certain large-sized projects, and sometimes it can be the subbies themselves, or like a roofing contractor, where we talk about air tightness.
Do you get a lot of questions during that kick-off meeting?
It tends to be a bit of absorption, and then when the questions come, it will be about their specific things. So, okay, what if I put a penetration in the internal wall? Do I have to seal that? And we'll say no, because that's not the air barrier. So we've introduced to them this thing called the red line on the drawing. So you need to know where you're working on your building. Am I on the red line part, which is the building envelope? And if I am doing the penetration, then I know I've got to seal that in a specified manner for that particular type of seal. So We've got a level of knowledge there because of the fireproofing that's done. People understand from the fireproofing perspective of things like smoke and prevent smoke moving all through a building if a fire occurs.
Yeah.
Sometimes when we bring that up, they then get it. Okay, air tightness is not so much the smoke, but it's that conditioned air. And then there are some, when we typically hear people with, for example, a UK accent, we'll generally ask them if you worked on air tightness, they're familiar with that. And say, oh yes, we've been doing it for many years. And sometimes we have a discussion about, well, where's a practice we do here in Australia that you do there because it impacts your air. So yeah, it's good from that point of view. And the secondary thing about those briefing things is to achieve air tightness, you need to use air tightness products. So that's going to be a corking system that allows an expansion and contraction. And air tightness products have a higher spec, they're going to last longer, and they've got more things like expansion, contraction ability. And the key thing with them is that you also have to read the instructions of how to prepare the surface. Sometimes they require a primer, sometimes they do not. And we've seen some weak parts of the construction occur because they've tried to seal it, but they haven't prepared the surface, and the taping they've done is no longer on when we come to test, if we can see it.
Sometimes it can come off and you don't even know about it.
That's right. You just go, it's happened somewhere. And not all buildings you can do an initial test because you haven't achieved air tightness yet. You can in the passive house because if you're using an air membrane, you can test it then. And then when the linings go on, well, you test again at that point, providing you maintain your air tightness. But yeah, it's just a range of things, but it really comes back to looking at what you do in terms of a build from a different perspective of something called air tightness.
Tightness, okay.
And what does that mean to how I do it? So this most successful projects we see are where someone on the project team takes air tightness lead role. We encourage firms to have it as part of their induction. You're working on a project that has air tightness as a requirement.
It's from both the builder/construction side and from the design side as well.
Yeah. So the people coming on site, these things apply. For example, if it's got an airtight air membrane wrap put on, don't believe leaning building objects against it that tear that. We've seen that happen. It's put a hole in something. It's because, what's a hole? It doesn't matter. It does on this project. If you've got a passive house target, very difficult to achieve. You've got to be fanatical. So that's what we do. And then we have site visits during the project, and that will vary the number of site visits depending on the complexity of the building and also whether there's staged zones of the building. We're working on a project at the moment that's got a basketball courts, a pool, and an
indoor pool,
and an office sort of complex. So three sort of distinct zones. They'll each have their own HVAC system, but air tightness in the aquatic areas. We met a guy some years ago, Sam Thorne, and he was telling us about pools and what air tightness means in the pool. He said, if you get good air tightness, he said, not only you not losing the energy, the heated air, he says, you actually end up having less evaporation. Less evaporation means less cold water coming in that you have to heat, for example. So a good aquatic centre today has good level of air tightness. Less than 5, sometimes it's less than 4 is specified in permeability. They also run a positive pressure in the pool zone, like about 5 Pascal pressure. And the reason they do that is that acts like a pool blanket on your water. So that again reduces
the evaporation,
which means you can have less condensation, which means less coring on metal fittings. It can be quite dramatic. The other thing you get with really air tightness, especially down at the passive house level, is you no longer have gradients of temperature in that area. What it means is that in that part of the house, it's going to be very similar temperature to another part of the home. And when I stand up, maybe it's a 2-story home. When I go upstairs, it's going to be a similar temperature. Because what happens is you get this molecular mixing of the air molecules at certain good air tightness. What it means is that you get this more even temperature of that environment. and which is good because you don't have someone saying, I'm cold here, turn it up. Someone saying, I'm too hot upstairs,
Turn it down.
turn it off.
Yeah.
Or they open the window, which just makes things worse.
Yeah. Yeah, creating the imbalance or making the imbalance even worse.
Yeah.
And maybe as we wind down, just the two last questions from your perspective or from some of the projects you've worked on. At what stage is it best to undertake the test? Is it once practical completion, or is it at multiple stages throughout the build? Or what's the most optimal stage?
Yeah, ideally, when you get to lockup, if it is airtight, and you can do it then, because then you've got access to whatever the leakage areas are. And I'll give you an example of a building we got involved on. Very late in the piece. The builder didn't realise they had airtightness as a requirement. It was a commercial project. And there wasn't a lot you could do at that point except test. And when we first tested it, it was something like air permeability of 26, way off the charts. Didn't even go close, and their target was to be less than 10. So a huge difference. And some of the areas were just very difficult to get to. For example, if you put in a HVAC system with your supply and return penetration through the roof, where the roof plant is, the way this one was constructed, they couldn't get at that point from above or below. And you could visually see daylight when looking up from below on the platform.
Where they projected
weathertight, had some
sealants and everything.
Yeah, it had it from above, but it wasn't airtight. That was something they couldn't do anything about. But there were some other areas where they knew what had gone on. And I thought, okay, well, that was an area, and they had to break open the plaster to get to those.
Yeah.
Then result we got on the next test, great improvement to about 30, but they'd probably reached that point where you couldn't do much more. Ideally, it's at lockup, but sometimes it doesn't, the way the building is, it doesn't really get to that point. And in the commercial place where we have suspended ceiling tiles, air barrier is not at the ceiling tiles. It's above that, which is going to be your roof
level.
Yeah. So your roof to wall is the typical weak areas in commercial buildings. You've got things like box gutters there. So you're transitioning from roof to box gutter to wall. So you've got to work out, how do I make each one of those airtight? It's not my conventional build because I'm not worrying about it. I'm just worrying about weather tightness. But air tightness, when you've got all this linear meters, you think of how large some commercial buildings can be, aquatic centres or 6-court basketball stadiums and so forth. Yeah. So if you don't, you can have a lot of leakage. But so that's what we will see probably about on a third of the projects. They'll ask for a test at lockup and then a final one. Most of them tend to just have our practical completion for the commercial. And for residential, if we get involved and provide you some advisory services, providing they're acted upon by the builder, you'll know you're going to get good air tightness for, let's say, conventional plaster build. So you can be confident you're on track. That's what we can do. And then, as I said, passive house is different again. You do it typically at least 2 tests, air membrane and practical completion. The passive house associations, their documents will specify 3. They'll say at the air membrane, and then the next stage before fit off. So you've got your lines on, but you haven't put all your cabinetry in and fitted off all your appliance points and so forth. Again, just so that you've got access to those if it's not meeting target. Because we find with a passive house, once it's built, where's your air leakage occurring? Because it's they don't leak at GPO points because they're made airtight. Where the cable comes through the air barrier, that's where it's sealed. So when it's eventually terminated, there's no longer an air leakage part.
Leakage there. And the last question is, which is more of a bonus question really. Is there anyone in the industry that you particularly follow or find interesting or insightful, just in the broader construction industry or even within the space you're in?
Okay. In terms of following, we've got the president of the AVA group, and he's also working with the ATMA, Sean Maxwell. He's been very good at raising awareness of air tightness. He's from North America and worked in that space. And he came to Australia and could see that not much air tightness is happening here.
Yeah.
So he's done really good in terms of doing presentations to different groups and so forth. And currently works for a group, ProClimate, who provide air tightness products, membranes and tapes and so forth. He's someone that, follow on like LinkedIn. And then other ones, I pick out some people, I think from North America. I can't remember the name, but they're a commercial company that does some massive buildings in terms of air tightness testing. To give you an idea, one fan is what we use on a residential building. But I've seen some tests where there's 30 fans testing like a big shopping mall. In terms of what we do, we've got a big one coming up next year, and it's going to need 11 fans to test the commercial building. That requires a lot of planning, and also the setup time. The test is going to be quite short versus the setup time, putting all that plant together and running it. And just explain how the test is done. There's different providers. We use a Retrotec fan door system, and we connect it up to the gauge, measures the pressure. The fan creates the pressure itself with a big positive or negative pressure, and then that connects into a computer. We've just got some software, and that does all the measurements, drives the fan and takes the measurements from the gauge and compiles that for us and generates a report. And we have to make sure that it meets things like correlation. It's got to be greater than 98.5% for all the test points you've done. So we've tested from 20 to 60 at 5 Pascal intervals. We take about 20 measurement points at each one of those. And then at the end of the test, it draws a chart and says, well, how are all those points, the correlation? So if it's good correlation, you meet that. And if not, you've then got to go and retest the point. So you will delete that and go into that pressure over that 35 Pascal. You must have copped a squall, and it's just dropped, caused an impact on the measurement readings. Redo that one, for example. And that's, we get a test report. So that's what's provided to the customer, not just the number. Hey, you got a result of 8 air permeability at 50 Pascal if you're seeking less than 10. But here's a report, and for those who are really technical minded, they can see all the math and all the data tables and so forth.
A little bit of an interpretation of what that means.
Yes. Yeah.
Gotcha. All right. Thank you very much, Ash, for joining us today, for sharing not just about yourself, your experience, but also what you do. Hopefully there will be another session in the future as the industry evolves and this particular component of building performance, which is airtightness, gets more adopted into how we design and construct, just to improve, as you mentioned, the comfort and energy performance as a secondary effect as well. So thank you. For the listeners, if people wanted to contact you, where can they find you?
Our website's www.3r.com.au. We've got some resources there, and also a web page for contact. And I've got a phone number, my mobile, 0409 040 321, if they want to have a chat about a project or whatever. We don't charge our time for inquiries. We basically try and identify what a person's trying to achieve and then give them some advice. And sometimes that could be, I recommend you have a chat with a designer who specialises in this field. If you're really wanting to get a super air tightness, you might want to look at an air membrane design. At that point, again, we talked about where we are in the industry, still early days. So there's a bit of education and passing on and helping people to understand. And we've got a document we just called Build Airtight, Ventilate, a few pages just on the topics to help people understand, well, what does it mean? Some links to more information. I find that helpful, especially if they've rung up with I've heard about this, but I don't really know what it means.
What it
Can you
is.
tell me some more?
Yeah.
So that's just a few page document that can assist.
Yeah. Awesome. Thanks once again. And hopefully we'll sit down in the future to expound on some of the ideas and the concept that you've mentioned today. And I'm pretty sure some listeners will most likely come in with questions. So maybe we can address them at a future date.
Sure. It's been good spending time with you today. I think it's a very important one.
Yeah. Thanks, Ash.